Good morning. Continuing with my lectures on projection of planes. In the previous lecture, I had shown you how to draw the projections of a triangular lamina when it is resting on its corner on HP. Okay. Now, in this lecture, I'll explain to you how to draw the projections of a lamina when it is resting on VP on one of its corners. Okay, so here when he says the lamina is resting on one of its corners on VP, so you have to imagine the lamina to be completely resting on VP in such a way that when it is resting on its corner, you have to imagine the lamina to be completely resting on VP such that the line joining the center of the lamina and the corner on which it is resting on VP is parallel to HP. So in this position you have to draw the front view and top view. Okay, in this the front view will be like this. Okay, when the lamina is resting on VP. So in the front view you will see the true shape of the lamina. Okay, and this will be the corner on which it is resting on VP. Okay, we will consider the triangular lamina itself. Okay, so here in the front view we will see the true shape of the lamina. So if it is an equilateral triangular lamina, this will be the front view. If this is the center, I told you how to find the center. Draw the perpendicular bisectors of two adjacent sides. You will know, the point at which they intersect, that will be the center of the lamina. So the line joining the center of the lamina and the corner on which it is resting must be parallel to HP. Okay, when the lamina is resting on VP on its corner, and the corner should be to your left. Suppose this is your corner A, B, A dash, B dash, because it is front view, C dash. Okay, so what will be the top view? If the lamina is resting on VP, if you look from the top, you will see only this edge, that is, it will appear as a line on the XY line. So draw the projectors from A and C. B and C will be in the same straight line. So this will be the top view of the lamina. In the top view, if you look from the top, you will see the corner A is visible, corner B is visible, and C is invisible. Therefore this is A, B, and in brackets C. So this is how you have to draw the projections of the lamina, equilateral triangular lamina, which is resting on VP on one of its corners. Okay, so if it is a square lamina, okay, if it is a square lamina, it must be drawn like this. That is, this will be the initial position. The line joining the center and the corner must be parallel to HP. This will be the initial front view, and this will be the top view. Okay, if it is a pentagonal lamina, okay, this will be the initial position. And if this is the center of the lamina, the line joining the center and the corner on which it rests must be parallel to HP. Okay, and if it is a hexagonal lamina, it will be like this, initial position. So here this will be the front view, top view in this case. Okay, and this will be the hexagonal lamina. The line joining the center and the corner on which it is resting is parallel to HP. So these are the initial positions of a lamina which is resting on one of its corners on VP. Okay, now coming back to this, here in this case, when the lamina is resting on HP, you have to after the initial position you have to fulfill the HP condition first. Now in this case, because the lamina is resting on VP, you have to fulfill the VP condition first. So usually VP condition, what he'll give is, he'll say the surface of the lamina is inclined to VP at some angle. Okay, so inclination with VP, it can be seen only in the top view. So if the lamina is inclined to VP like this, then in the top view you will see the inclination. So you have to lift the lamina. See, this is the vertical plane, the lamina is like this. If you look from the top, earlier it was like this and now it has become like this. So in the top view you will see a line which will, this line will move from the XY line, but because A is resting on VP, okay, in the top view it will always be on the XY line. So draw a line inclined at some angle, whatever he has given, theta 5, that is 5, equal to this length. So draw a line inclined at 5 degrees. 5 may be 30, 40, 45, whatever is given in the problem. So the length of this line, inclined line, must be equal to this, A and B. So measure A and B and mark it here. So this is B and C in brackets. Then project the corresponding front view. A, draw the projector from A, and from the previous front view draw a horizontal projector to cut it. So this will be new A dash, and from B and C draw the vertical projector. So from previous front view of B, draw a horizontal projector. This will be new B dash and this will be new C dash. Join A dash, B dash and C dash. This will be the new front view of the lamina, which is resting on its corner on HP and surface is inclined to VP at corner on VP and surface is inclined to VP at 5 degrees. Okay, so next is what he will give. He may give that the edge opposite the corner on which it is resting is inclined to HP at say some angle, that is theta. Okay, so what you have to do, you have to take this edge on the angle which is given to you in the problem. So if this is theta, so this edge must be here now. So measure this B and C dash. This is B dash and C dash, and I told you have to redraw this top view here. Okay, so many students, some of the students have submitted the assignment. What they have done, they have drawn the first top view here. That is wrong. You have to draw this second top view here, second front view here. Okay, so with this you measure this distance A dash and B dash, C dash, and A dash and B dash, it will be same. So take this as radius, A dash B dash as radius. From B dash draw an arc. From C dash cut the arc. You will get the point A dash. Join A dash, B dash and C dash. So this front view you have drawn in this position. Now project the top view. Okay, so in the top view, A is on the XY line, so A will be on the XY line. B and C, draw the projectors, vertical projectors from B and C. So from the previous top view, so project the horizontal projector. This will be B and this will be C. Now join ABC, you will get the top view of a lamina whose surface is inclined to VP at 5 degrees and the edge opposite to the corner is inclined to HP at theta degrees. So phi and theta may be any angle. Okay, so this is the type of problems you will get. Okay. The same problem you will get for pentagonal lamina. So if it is a pentagonal lamina, I'll just show you here. resting on its corner on VP. Okay, so this is the center of the lamina. So you draw it to scale. Let this be A dash, B dash, C dash, D dash, E dash. So the front top view will be a line on the XY line. Okay, when the lamina is completely resting on VP, the front view will be the true shape of the lamina and top view will be a line on the XY line. Okay, next this will be A, B and C. If you look from the top, you will see A, B, A dash, B dash and C dash. So A, B, C are visible in the top view and D is invisible and E is invisible. Okay, so next fulfill the VP condition. This is the initial position and next is the VP condition. So VP condition, what he'll say, the surface is inclined to VP at some angle, say 45 degrees. So A will be here, measure AB and mark it here, this is B, then measure BC and mark it here, this is C. Okay, so this will be the new top view. Then project the front view, draw the projectors from A, you will get A dash, from B, and this is also E and D. B and D, draw the vertical projector from the previous front view. You draw, this is B dash and this is E dash. Then from C and D, draw the vertical projector. This will be E dash and this will be new D dash. So join A, B, C and D. You will get the new front view of the lamina whose surface is inclined to HP at 45 degrees. So you can see the difference. Okay, so here. Now next is what? The edge opposite to this corner is inclined to HP at some, say, 30 degrees. So what you do, you draw a line inclined at 30 degrees to XY line, that is 30 degrees to HP, and then on that line take this edge E and D, E and D dash. Let this be E dash and let this be D dash. Now draw this front view in this position. So how to do that? You just draw a line here. This line will bisect D and E, okay, and joins the corner on which it is resting. So from here, and it is perpendicular to D and E. So find the midpoint of E dash and D dash. Draw a line perpendicular to E dash and D dash. The length will be equal to this. Okay, so here we will get the point A dash. How to get E dash and B dash is, see, you measure this distance from here to here and mark it here. Okay, then this line you can see E dash and B dash, C dash and B dash is parallel to E dash and D dash. So draw a line from this point, draw a line parallel to E dash and D dash. Draw a line parallel to E dash and D dash. All these are construction lines. There must be thin lines. Now measure this distance from here to B dash, from this point to B dash, and from this point to C dash. Both will be same. So measure the distance from this point to B dash with that as radius. With this as center. Cut this side and this side. You will get the points. Oh, sorry, this is C dash and this is E dash. Okay, so this will be B dash, then this will be E dash. So join this, then join A dash, B dash, C dash and E dash. This should be the new front view. So this is the HP condition. This is the HP condition, and this is the VP condition. Second set of views is the VP condition, and this is the HP condition. Now project the top view. So draw from A is on the XY line. From here draw a vertical projector to cut the XY line. This will be a new A. Then B, draw a vertical projector. From the previous top view draw a horizontal projector. So this will be B. And from C draw a vertical projector. And from the previous top view draw a horizontal projector. This will be C. And here D, B and C and D are both in the same line. So this will be your D, and E, this will be the point E. So join A, B, C, D, E. You will get the required top view of the pentagonal lamina, which is resting on its corner on VP. Surface is inclined to HP at 45 degrees, and the edge opposite to the corner is inclined to VP at HP at 30 degrees. So this is how you have to solve the problems. So please refer to the question bank, VTO question bank. Find out these two problems. You will get in this type. You will get problems only on triangular lamina and pentagonal lamina. Okay. So please refer the VTO question bank and then try to solve the problem. So one more type of problems you will get in this. Okay, when the lamina is resting on VP and its corner, one more type of problems you will get, that is the median passing through the corner, as you have studied in the lamina resting on HP, okay, on its corner. Here also, when the lamina is resting on VP, the median passing through the corner, he will say that it is inclined to HP and inclined to VP. Okay, so the problem will be like this. We will take the equilateral triangular lamina. Okay, so and equilateral triangular lamina of side, say 25 mm, is resting on VP on one of its corners, such that the median passing through the corner is inclined to HP at 30 degrees and to VP at 45 degrees. Draw the projections. Draw the projections. The same may be considered for pentagonal lamina also. So in this case, draw the equilateral triangle. Imagine it to be resting on VP. Draw the equilateral triangle like this, so that the line joining the center and the corner is parallel to HP. Okay, so draw the median from here. So if this is A dash, B dash and C dash, let this be M dash. A dash M dash is the median passing through the corner on which the lamina is resting on VP. So draw the corresponding front view. The front view, corresponding top view. The top view will be a line on the XY line. So this will be, if you look from the top, A and B are visible, A and B, and C is invisible, so it will be in brackets. So this will be the initial position. Next is the HP condition. What is the HP condition? The median passing, next is the VP condition. Because the lamina is resting on VP, you have to take the VP condition first. So he says the median passing through the corner on which the lamina is resting on VP is inclined to VP at 45 degrees. So here M dash also will be here, it will be hidden, so M will be hidden. So when this median, it is like this is the median. Okay, so suppose this is A and this is M, this is the median. Okay, and this is the vertical plane. Imagine this to be the vertical plane. It is like this. Okay, so when the median is, he says the median is inclined to VP at 45 degrees, you have to rotate the lamina so that this corner is still resting on VP. Okay, and the surface becomes inclined to VP at 45 degrees. Now this is the position which is given to you in the problem. So this will be seen only in the top view, correct? So if you look from the top, you can see this will be the initial position and this will be the VP condition. So here in the top view, what happens to the line? The line gets inclined. So this is A. Draw a line inclined at 45 degrees to the XY line. So this inclination is 45 degrees. Okay. Now, what must be the length of this line? It must be equal to this, A and B. Measure AB and take delectors radius from A, cut it, you will get this B and C in brackets. Okay, and also M, we will call it as M1. Okay, we will call this as M1 in brackets. So draw the projectors to project the front view. Draw the projectors from A. Okay, you will get the new A dash. Then draw the vertical projectors from B and C. You will get the new B dash and C dash. Join A dash, B dash and C dash. And M, you can see, draw the vertical horizontal line here. So this is M1 dash. Okay, as you can see, because the median is inclined to VP, in the front view it appears as smaller in size. You can see this is the actual length of the median and this is the apparent length of the median. Okay, now he says the median is also inclined to HP at 30 degrees. So what you have to do is, he has given the true inclination of the median here. So draw a line inclined to HP at 30 degrees. Okay, like this. Draw a line inclined to HP at 30 degrees. On this line, you take the true length of the median. This is the true length. Okay, please be very careful. You have to take this length because it is true inclination. Okay, so A dash and M dash you measure from here. A dash and M dash. So you take it here. Next, draw the locus of, suppose this is your M. Okay, and this is your A dash and M dash. Now through A, draw the locus of A. This is called as locus of A. Now take the apparent length from the previous front view, that is A dash and M1 dash. take this as radius. Take A dash and M1 dash as radius with M dash as center. Cut the locus which you have drawn. So this will be the actual A dash. So join this. So this must be the position of the median in the third set of views. So this is the HP condition. Okay, because in lines you have studied that if a line is inclined to both HP and VP, you will not be seeing the true inclination or true length either in the front view or in the top view. So this is how you have to find out. Now this edge A, B dash and C dash is perpendicular to A dash and M1 dash. So this is we'll call it as M1 dash. Okay, so A dash and M1 dash. Then draw a line perpendicular to A dash and M1 dash here to complete this figure. Then measure M1 dash and B dash and M1 dash and C dash. They will be same. So measure M1 dash and B dash. Mark it here. This is B dash and mark it on this side. It will be C dash. So join A, B and C, A dash, B dash and C dash. You will get the new front view of the lamina. So project the top view. In top view, A will be on the XY line. A, B will be below the XY line. This is B and C will also be in the same line. This is C. So join A, B and C. This will be the top view which is required. So this will complete the problem. Okay, so these are the problems which you will get both for triangular lamina, square lamina, pentagonal lamina or hexagonal lamina. So find out which are the problems in the question bank and please solve them, because I don't have the question bank with me. Okay, please refer to the question bank and solve the problems which are wherein you will get the lamina to be resting on VP on one of its corners. Median is inclined to HP and VP. Okay, thank you.